Okay, everybody. I don't know about you, but I don't want to be here tonight. I kind of like that week off, but we're stuck. We have 3 more weeks of class. 2 of those are going to be covering chapter 11. 1 of those is for the final exam. We got a lot to do in 3 weeks, a lot. I want to go over some things I put on the last email I sent you. Make sure everybody is clear on this. And if you're not clear, you can ask now. If you're still not clear, email me. I'll be happy to answer or clarify any questions. First, 2 Thursdays, well, not this Thursday, but the next Thursday, on December 9th, okay, we'll be taking our chapter 11 test or exam. It's exam number 4, okay? The date is wrong. It says Thursday on my syllabus, but it has the 8th. It's the 9th. It's a Thursday when we're in class. So double check that. I've made that correction in MOM, so make sure you know. For chapter 11, no quizzes, no homework, okay? You do what you need to do on MOM. If you don't need to do any of it, or if you only need to do half of it, great. Just do half of it. If you need to do all of it, do all of it. That's totally up to you. Okay. But I'm not going to grade it at all. Okay. It's still there, whatever. For the test, for exam number 4, chapter 11, essentially, you will be allowed to use a 3x5 note card. 3x5 note card, standard one you get at the bookstore. I will give you one on Thursday in class if you don't have one. Okay. It must be handwritten. All you computer geeks, who sit there and you can get size 3 font and print the whole text on there, that ain't going to cut it. It must be handwritten. You can put anything on it you want, front and back. I don't care. Okay. You can also do a brain dump. So if you have all this on a note card and then get out a piece of blank paper and do a brain dump right before the test, that's cool too. Okay. But you will be allowed for the chapter 11 exam number 4. Okay. You'll be allowed to use a 3x5 note card. All right. Questions about that? You sure? Okay. Next, our final exam. Okay. We have, this gets a little bit confusing. Our final exam, okay, part 1 will be Wednesday on 12/15. It will cover chapters 8E, 8I, and 9. I've written it. It's already, well, I've put in the finishing touches on it, but that's what it's going to cover. 8E, remember we had an 8 elementary and then an 8 intermediate and then a chapter 9. Okay. This gets confusing, but let me do this. Part 2, okay, will be Thursday, 12/16 on 12/16. It will cover chapters 10 and 11. Now, some problems. Okay. First off, the best place to study is your old exams. Because, excuse me, what I've done is every semester I look over the old exams. I find the questions that I think are super important, and I take those questions right off of your old exams. Now, I do change the numbers. Okay, so they're the same question, slightly different numbers. You got to know how to do them. If I change the numbers, I generally make it easier. My logic there is when we're studying like specific ideas, right? We're chapter 8E and 8I. Then we're really focused on that. So I feel that justified in giving you a little bit trickier, harder problems. But when we're taking our final exam, we're covering the big ideas. So I don't want to trick you. Okay. I don't want to make it just really tricky and dirty problems, stuff like that. I want to see, do you know what you're doing on those things? So I make the problems a little bit easier. Same problem, easier numbers. Okay. The best place you can do is go over all of your old exams, make sure you know how to do all those problems. Remember, I put all the solutions up on Canvas. You can see all the steps, you can see everything. Okay. Those can be questions that you ask before class. When we start class every night at 6 o'clock from 6 to 6:30, I'm sitting here staring at the screen. Nobody asks questions, which is okay, but that's a prime time to ask me a question about, hey, on chapter 9, I really didn't understand question number 3. Can you go over it again? Sure, I will. No problem. Okay, now we have some issues here. First, any questions so far? Okay. This part of the final exam on that week is going to be it's going to be online. Okay. So you're going to have to take it at home and email it to me. This is why I want to make sure you can use a PDF. You're going to have to email a PDF copy of solutions before the end of the evening. What I'll do is I'll on Canvas in the final exam module, I'll have it there. It will be available to you starting at 6 o'clock. Okay. You take it. Okay. Use your PDF copier. Okay. That's on your smartphone and take pictures of it and email it to me, but it must be in PDF. Okay. My computer does not read Apple, HAIC, or whatever that thing is, doesn't read it. If you send me something I can't read, it's wrong. And you've just lost half of your credit on the final exam. So because of that, I'm going to let you practice. We have a PDF quiz. PDF, idiot, quiz. That's due this coming Sunday. Okay. What it is, it's a chance for you to practice using your smartphone in a PDF. So you need to download a free PDF maker app for your smartphone, and I'll show you one in a moment that I like. Okay, if you have one already and know how to use it, great. Okay, you're ahead of me. Okay, so download a free thing for your phone. It's cool. Then what you want to do, I want you to create a single file, one picture, whatever, one thing, but it has to be 3 pages long. Okay. The first page has to be some textbook. You take a picture, you find your favorite textbook. It doesn't have to be a textbook. It could be the current book you're reading from the library. It could be a newspaper, but you just take a picture of it. Text, already pre-written text. The second page, okay, I want it to be a picture that you draw. Now, hang on, before you panic. Okay, okay, that's good enough. If you just draw a stick figure, now if you're a really cool artist and want to draw something neat, great, do that. But that's good enough. I just want to see, can you take a picture of a drawing? That's all I want to see. Okay, third page. I want you to do some handwritten. Okay, it could be a poem or a limerick. I would prefer a limerick because they're fun. Okay, it could be an inspirational message. Okay, it could be something like, "Hi, Foster." Okay, this is not an overwhelming assignment. Okay, but what I want you to send me is one email with a file on it that has 3 pages long. First page will be a picture out of a textbook. Second page will be a picture that you've drawn. Third page, something that you've handwritten. Okay, one file with 3 pages in it. That's kind of important. Okay. The other thing you need to do, and I may send it back to you. That's why it's so important. If you did it tonight and send it to me tonight, I can look at it and say, you can do better. It needs to be dark, okay, and readable. Because when you send me this part of the final exam, if you send me something that's so light and I can't read it, how can I grade it? So this is our chance to practice. Okay, instead of a handwritten poem, message, or something, maybe do a math problem. And I can look at it and say, hey, that's pretty good, or no, you need to darken it up. Okay, this is simply practice for you, so you know what you're doing, okay, for this final exam. I don't want you to fail the final exam because you can't send me a copy of your work.
I have a silly question, Professor.
Okay.
We're not taking our final exam at Mesa College?
Well, no, we're not. Okay.
Oh,
Okay, hang on. Time out. Yes, we are. No, we're not. Okay. Our class is set up. I would love to force you all to come to class one extra day, but I don't think I legally can. We're already coming to classes on Thursday. That's when we'll take part 2 of the final exam. But on Wednesdays, those have always been Zoom nights. The class has been on Zoom. So I'm going to give you my test on Zoom also.
okay, I understand.
Okay. I would love to have us all come on campus 2 nights that week, but I don't think legally I can.
Oh.
And so I don't want to make waves. So we're just going to do it this way.
Okay, sounds good.
Okay. That is not a silly question. That's, we need clarification on that. So good call. Okay. I want to show you guys something. Okay. Can everyone see? Boom. I'm on Canvas, okay? I'm in the module system. Can anyone not see that? Okay, no one's yelling at me yet. Okay. This is okay. Chapter 11. Nice little video there. Watch it or don't. It'll explain what we're doing in chapter 11. Eventually, I'm going to teach you this. These special triangles. If you already know how to do it, great. Okay. If you don't, okay, I'm going to teach it to you, but you might want to download that worksheet. And I'll put some more things here in chapter 11. For exam number 4, which is essentially chapter 11, I've given you a topic breakdown. How many of each type of question is going to be there? Okay, so you can look at that on your own. But for chapter 11, I'm going to add more here, including videos, including worksheets, including stuff like that to help you. But this is the topic breakdown. This is 2 Thursdays from now. Okay. Is it the 20th? Is that right? That's wrong. Oh, that's way wrong. I got to fix that. Date's wrong. I'll fix that. Okay. Next, final exam. Same thing I just told you tonight. Okay. About it's going to be in 2 parts. Okay. And this file here, you can look at it on your own time. I'm telling you exactly how many problems I'm taking from each chapter. I will tell you that the majority of the problems come from chapters 9 and 10, mostly 10. 10 is logarithms and exponentials and functions and compositions and inverses. Okay, that's chapter 10, and that's the majority of the final exam. Yeah, now by majority, that's like, 45, 50%, but that's a lot. Half of the final exam will come from 1 chapter. Okay, so look at those on your own. Again, when we start class, in the evenings or stuff like that, if you have questions about what I put online, that's a prime time to ask me those questions. Okay, if you want to email me and ask me questions. Now, I'm going back to my home page. Okay. This is the home page down here. It's got all kinds of crap on it, stupid stuff. But down here, I talk about at the very end, I talk about downloading apps that will allow you to convert your photos into PDF files. Okay. The one students seem to like most is called Cam Scanner, but there are others. Do not get suckered into paying for it. Don't. Okay. And don't put a password on anything, please, for God's sakes, because I don't have your password. When you password protect it, okay, then you send it to me. I can't open it because I don't have your password. If I can't open it, I can't grade it. The other thing, okay, so you download one of these, you kind of look to use it. YouTube can teach you everything you need to know. Okay, but if you go to resources, the resource module, which I will go to right now, boom, okay. There's a, right here, it says use Cam Scanner to make a multi-page PDF document. Bingo. That's exactly what I'm asking you to do. So here's a video that I found on the internet. I copied the link, and it shows you how to make a multi-page document, just like I'm asking you to do. So again, I'm putting everything there for you to use prior to the final exam, part 1, and prior to this coming Sunday. Okay. I would like to start actually teaching instead of just going over this junk. So does anybody have any questions about anything I've said about chapter 11, about final exam, about the PDF quizzy thingy, whatever I'm talking about? Any questions? Okay. Boom. All right. So having done all of that, okay, I'm praying that you guys will contact me if you have any questions about any of these things. Okay, I would hate to have your grade suffer because you don't understand or because there's miscommunication between you and me. Okay, here we go. I want to erase the board and get into new material, chapter 11 stuff. Okay. I'm going to do chapter 11 a little bit out of order. I'm going to try and take care of most of the easy stuff tonight. And tomorrow night and Thursday night, we'll deal with the uglier stuff. Okay, tomorrow night, whatever, we'll do that. So tonight, in chapter 11.1, we're going to learn new formulas. First formula we're going to learn is called the midpoint. Okay. Let's say you had a segment here, and this is the point 9, 4, and this is the point -4, -2. Okay. So we have a segment. I want to know what point is in the middle. Okay, now it's real simple. The midpoint is the average. That's all it is. Now the book, Mom and all other books have a fancy formula. They use capital M for the midpoint. And then they go something like this: x(1) plus x(2) over 2, comma, y(1) plus y(2) over 2. And it looks really scary because it's got all these sub-1s and sub-2s, and it's got fractions and crap. All it is the average of the x's. Because remember, when you average two numbers, you add them up and divide by 2. So that's all that says. Take the first x, add it with the second x, divide by 2. First y, add it with the second y, divide by 2. That's all it is. Okay, the midpoint is this. So in this particular problem, it would be -4 plus 9 divided by 2, and the y's would be -2 plus 4 divided by 2. So clean those up. That would be 5 over 2 or 2.5. I don't care. That would be 2 over 2, which is 1. So we'd say that's the midpoint, 2.5, 1. And usually when you put it on the line, you do use the capital M for midpoint, and you would label it as 2.5 or 5/2, 1. That's the midpoint. It's that simple. It really is. Okay, so, and there is probably the first question on exam number 4. Let me see where my notes. Okay, so I want you to find the midpoint between these 2 points. Suppose point A was 2 radical 5, 6, and point B was negative 12 radical 5, comma 1. Find the midpoint of those. You don't have to graph it. You just have to find the midpoint. Hmm.
Professor, I think the x should be -5.
You're right, because it's negative 12, negative that. Thank you. Is that okay with everybody? And yes, I will have radicals on the chapter 11 quiz or test rather, or exam 4, whatever it's called, because I need you to review those because those will actually show up on the final exam also. Add and subtract, multiply, divide, radicals. Okay, so I'm using this to review. Okay, questions about that one? Or questions about the midpoint in general? Okay, then still, I want to stick with this point here, the 4, -2, and the 9, 4, that point. Can you find the slope of that line? You should be able to because it's back in chapter 2. Can you find the slope of that line? Okay, remember slope was rise over run. And rise means up and down, which means you put your y's on top. We write delta y. Delta is the triangle. That's the Greek letter triangle. Okay, delta. And it means the change in y over the change in x. And the reason I review that is because that helps you to remember the formula that everybody panics on. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, stressing rise, delta y, y is on top. People always forget who's on top, okay, who's on bottom, and by now you should know it matters, who's on top and who's on bottom. So rise means the y's is on top. Okay, so when you go y sub 2, I'm going to get 4 minus -2 over 9 minus -4. Remember, the formula has its own minus in there. Okay, so you just have to put the numbers in and deal with the minus. So 4 minus a minus 2 is 6. 9 minus a minus 4 is 13. So the slope of this line is 6 over 13. That means we went up 6. Think about it for just a second. From -2 to 4, from -2 to 4, we went up 6. When we went sideways, 13. We say run, okay, but so from -4 to 9 is 13. So when we went from -4 to 9, 13, we went up 6, and that's exactly what that says. Okay, the last thing I want you to do with this same problem is find the equation of the line here. Now, this is a segment. A segment has a start and a stop point, but a line continues. It goes through the segment and goes out. I want you to find the equation of that line. Okay, you have all the information you need. Take a second or two to think about it. Okay, we started with this formula, y equals mx plus b, that was called the slope-intercept formula. And we plug in what we know. We know that the m is 6/13. What else do we know? Well, we know that the x and the y is this point or this point. So you pick one of those two and you plug them in. You know that they're part of the line. So we can plug those in also. So I'm going to use this one. I'm going to use 4 for the y equals 6 over 13 times 9 plus b. Okay. Now, at this point, you're going to do everything on your calculator. So this is 4 equals 6 times 9 is 54 over 13 plus b. Okay, you're going to take away 54 over 13 from both sides. And let your calculator do the work. Okay, it's going to be some negative number, something like 2/13 negative, I think. I'm doing it in my head, but we'll see what my calculator shows me. Because we've seen.
That's correct.
Is that right? 2/13 negative?
Yeah.
Okay. You guys want to trust me? Or trust him? Okay, we'll just go with it and let you guys think. Okay, so this is going to turn out to be -2/13 equals b. But we're not done, because now we have the answer. The equation to the line was y equals 6/13 x, minus 2/13, because that was the b value. And again, let your calculator do the ugly math. That's why you have one. Okay. So the first 3 questions you're going to get on exam 4 are right here in front of you. Maybe not these numbers, but they're right here. I'm going to ask you to find the midpoint of a segment. I'm going to ask you to find the slope of a segment, and I'm going to ask you to find the equation of the line that goes through the segment. There's the first 3 questions right there. Okay, again, we're reviewing, we're spending one of my reasons, and I've said this before, one of my reasons why I like chapter 11 is because it gives us a chance to go back and review all of our topics from the whole semester. All right, now I need to erase this, or most of this. Is this okay for midpoint, slope, equation of a line? I guarantee that that's the first three questions. Okay, then, still going with this picture. Okay. So we have midpoint, slope, equation of line. Okay, those are all topics that we covered right now. I want to know the length of the segment. In other words, how far was it from here to here? We know what the slope is. The slope is kind of a measure of the slant. We know what the midpoint is. But how far, if you were an ant walking, what distance would you travel from here to here? Now, I'm going to give you the preferred formula that you need to know, I'll say, in the future. Tomorrow night, when I review this, I'll show you a slightly simpler way, but I want to show you the formula that everybody assumes you've been taught. Tomorrow night, I'll show you the formula again, but I'll also show you a slightly easier way. Okay? The formula that people want you to know, okay, for future math courses starts with D. D means distance. It's the same as the length. Distance, the distance from here to here. Okay. It starts with a big, scary square root. And it's x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Okay, that's called the distance formula. Some people like to square both sides so the formula isn't quite so scary. So if you squared both sides, it would cancel out the square root. So you get distance squared is this mess. Whatever. The top one is probably the one that 90% of mathematicians would want you to know. So let's use this formula. Okay, what's it say? It says take the second x minus the first x and square it. So let's do this over here. Okay, D equals, I'm going to go with this. Okay, second x, 9, minus first x, -4, squared. Second x minus first x. Notice it's got minus a minus. Be careful with your signs. And then it says square the quantity. Plus second y minus first y, quantity squared. Okay. So now it's just a matter of arithmetic. So this is D equals the square root of, this is 13 squared plus this is 6 squared. Remember, Aunt Sally, PIMDAS, you have to do inside the parentheses. 9 minus minus 4 is actually plus 13. Okay. 4 minus minus 2 is actually plus, so it's 6. So this becomes D equals the square root of 169 plus 36. Excuse me. I don't know what that is. $205. Okay, so this is the exact length or distance from one endpoint to the next endpoint. That's exact. Now, the reason we say exact is because I haven't used my calculator yet. Okay, that's just it. It's exact. If I said approximate, okay, then we're going to square root this. Okay. And I get this D equals 14.31782. And this is the approximate length or distance. And then we tell you something about rounding it to whatever, tenths or hundreds or thousands. So exact means don't use your calculator. Leave square roots as square roots. Approximate means do use your calculator and then round it according to some directions that were there. So there is the fourth question you're going to see on the exam. First question, midpoint. Second question, slope. Third question, find the equation of the line. Fourth question, use the distance formula to find the length of that line. Okay, let's try one on your own, just to make sure we kind of have it. I'm not going to worry about slope and equation of line. We've done that. You can study that on your own. Can I erase this board, this work? You guys all have it in your notes. Okay, I will erase. Okay, so let's just make up a number. Suppose we have A is -7, 15, and B is 2, 25. That's good enough. Okay, the first thing I want you to do is find the midpoint. The second thing I want you to do is find the length of segment AB. That's how we write it, from A to B, the length of that segment. How far is it? And I want you to give me an exact answer. And I want you to give me one that's rounded to the nearest tenth. So let's pause and let you guys work on that. Okay, so the midpoint is simply the average. So that would be -7 plus 2 over 2 and 15 plus 25 over 2. Clean it up so that's -5 over 2. Not much can happen with that. Comma, that's 40 over 2. So the midpoint is -5 over 2, comma 20. Is that okay for midpoint? Okay. The length, okay, D equals big square root of second x take away first x, quantity squared. So 2 take away -7, quantity squared, plus second y take away first y, 25 take away 15, quantity squared. It doesn't matter who you call second x and first x, as long as you're consistent. Because one of the cool things about this formula is I'm going to get 9. And when I square it, I'm going to get 81. If you got -9 here, if you switched your x's around, you'd get -9. But -9 squared is still 81. So you can't go wrong as long as you don't make an arithmetic mistake. So this is d equals square root. This will be 9 squared plus 10 squared. So 81 and 100. So d is the square root of 181. Okay, this is my exact answer. It does not simplify. You can push that in your calculator and see, does it simplify in any way? No, it doesn't. Okay, but if I push that in my calculator, if I FD it, okay, I have D is approximately 13 point, what did they say? It's 453. So I said round to the nearest 10th. So 13.5 is our rounded approximate answer. It's okay for everybody. Any questions? Okay. Now, so the big topics so far in chapter 11.1 are finding the midpoint, finding the length of a segment, and I've added slope and equation of a line as a review. But when you do MOM, it'll be midpoint, length of a segment, utilizing this formula. Read the directions on MOM. Okay, remember homework is optional at this point, but read the directions. Sometimes they'll want the exact answer. That means don't use your calculator. And sometimes they want the rounded answer. All right, I want to move on to new topics still in chapter 11.1. Anybody have any questions? Anything you're copying down or you want me to clarify before I erase? Okay. Then another thing in section 11.1 is everything you never wanted to know about a circle. Everything that you didn't want to know about a circle. Some basic vocabulary, and then we'll get into doing some stuff. When you have a circle, okay, from the center to the edge is called the radius. Okay. From edge to edge through the center is called the diameter. Yeah, that's not very good spelling. Can't read it. Better. Okay. Around the outside is called the circumference. And it's not important at this time, but something that goes from point on the circle to point on the circle, but not through the center. Notice the end points of a diameter, the diameter goes from circle to circle and it goes through the center. This thing here goes from point on the circle to point on the circle, but does not go through the circle. And for your information, it's called a chord, C-H-O-R-D. That will be important in the future. It is not important in this class at this time. So just so you know, there is a name for that piece of the circle. Okay. One thing that we talk about in a circle is all points, listen to my words, all points that are equidistant from a center point. Equidistant, equal in distance. So all of these points along the circle are the same distance from the center. The radius is always the same from center to edge of circle. Okay, the distance is the same. You'll read that in the definition that will come up later. Now, here's the formula you need to know. X minus h quantity squared plus y minus k quantity squared equals r squared. This is the formula we're going to use for a circle at this time. H comma k is an ordered pair. It's a point, and it's the center of a circle. R is the radius. Okay, and I will ask you to always label the center and news, N-E-W-S. That is not in MOM. That is not in any other textbook. That's just my way of asking you to label special points. And I will show you how to do that in about 2 seconds. Okay. You do need to have memorized that this is the equation of a circle. X minus h quantity squared, y minus k quantity squared equals r squared. That's the equation of a circle. Okay, so let's take an example. And I'll explain what news means in a minute. Suppose I gave you x minus 3 quantity squared plus y plus 2 quantity squared equals 5 squared. Suppose I gave you that. Okay. And I ask you, okay, what's the center? What's the radius? And graph it. Okay, that's going to be a redundant question that we're going to go over it and over it about 1 billion times on this exam. I'll give you some equation. Okay, here it is. Okay, what's the center? What's the radius? Graph the sucker. Be sure to label what I've told you to label. So the center, be careful. The center is 3, -2. If you've fallen asleep, wake up. Okay. Compare.
Is this supposed to be -2?
Nope. Nope. I did it right this time, believe it or not. Okay.
Okay. All right.
I see, I deserve that because I made so many screw ups this semester. You guys are used to challenging me, and that's okay. Okay, but no, this time I haven't screwed up. Look at the formula. It says x minus h, use the h. That's what I did. X minus 3, use a 3. Then it says y minus k. But whoa, wait a minute. I have a y plus 2. Okay. Technically, what I should have shown you is this. We should have rewritten this way. so that our formula, our equation matches the formula. The formula has minus signs in it. So we want our equation to have minus signs in it. So x minus 3, x minus h, so my center is 3 because of that. Okay, I had to rewrite, instead of y plus 2, I had to write it as y minus a negative 2 because the formula has a minus. Okay, so y minus k. My k value is negative 2. I did not screw up this one time. Okay, and my radius is 5. Okay, let me show you a slight trick. People, students, your people, so okay, don't like this trickery that I did there. It bugs them. Okay, it's correct. I've made no mistakes. In fact, that's mathematically a very solid argument I just made there, but students still don't like it. So what students have learned in the past is when I'm using these formulas, I take the opposite of common sense. You see a minus 3, you use a plus 3. You see a plus 2, you use a minus 2. That's how most students think of it for a while. You use the opposite of what common sense tells you. Okay? I don't care how you trick yourself, how you learn this, as long as you use the correct center and the correct radius. That part doesn't matter to me. Now let's graph this sucker. Okay, we're going to start at 3, negative 2. Whoops. I get out of the way in a minute. Okay, so there's my center, 3, negative 2. Now, from that point, I know I can go 5 in all directions and hit the circle. If I go 5 units this way, I'll hit the circle. If I go 5 units at an angle, I'll hit the circle. If I go 5 units up, I'll hit the circle. Okay, the radius will always go out the same amount and hit the circle. So now I need you guys to be thinking on this one because this is kind of weird. Let's say I start here at the center and I go 5 units to the right. Okay, what value changed? When I moved sideways, did the x change or did the y change? When I moved sideways to the right,
X, right?
x did.
Yeah.
Yeah. So I went over 5, and this new point will be 8, negative 2. How? Because I moved 5 in the x direction. What if I move 5 backwards? Okay. I'm at 3, but I move backwards 5. I'll be at negative 2, negative 2. Okay, because I moved backwards 5. Well, what if I wanted to go straight up? When I go up, I change the y value. So I'm going to go up 5. 1, 2, 3, 4, 5. When I go straight up, the x does not change, 3, but the y does. Negative 2 plus 5 is also 3. And I want to come down 5, right about there. So this will be 3, negative 7. And Don't laugh at me because I will see your graphs on the test, on the exam, and I will be able to laugh at you too. That's my circle. Now, what do I mean by label the center? There it is, the ordered pair. I showed in the center. And what do I mean by news? North, east, south, west, or however you want to label it. Basically, it's the four corners. So I went to the right, straight up, to the left, straight down. But I move sideways, the X value changes by either adding or subtracting 5. When I go up and down, the Y value changes by either adding or subtracting 5. Okay. The exam number 4 will say, make a big, neat drawing. You're going to have your own paper. You could make this as big as you want to make it so that it's readable and so that it's neat. If you want to get graph paper and cut and paste it so you can turn it in, that's cool. You can do it on, you can take your graph paper into the classroom, okay, and do it on graph paper. I don't care. But that's a pretty good one. I guessed at it. It's a pretty good drawing, and you would get full credit for that. Questions? Okay, before we do another problem, I want you to state the domain and the range of this graph. What's the domain? The domain is all possible X's. The range is all possible Y's. Take a second to state the domain and the range. Okay, so the domain is all possible X's. Domain. They range from -2 to 8. Okay, bracket, -2, 8. You need to use this because we want to be able to pick up all the little fractions and decimals and radicals and everybody between -2 and 8. Okay, the range is all possible Y values. They go from -7 to 3. So the range like that. Okay. Again, we've studied domain and range. We've asked these questions. We're just going to continue to ask them. All right. I'm going to do another problem here where I'm going to give you the equation of a circle like this, ask you to graph it, label, the news, the center and news in EWS, and domain and range. Before I erase, any questions?
Hey, what does it say on the circle, right on the red part on the level?
Chord, CHORD.
Okay.
That, and again, that's not a critical thing for this class right now, CHORD. It's just a segment that connects 2 points of the circle, but does not go through the center of the circle. Okay, it's just think of it as a stupid vocabulary word. Okay, the only thing, most people get this and do really well on it. The only thing that screws people up is picking the HK, which is the center, picking it out of the equation. Okay, they didn't like that you see mentally a -3, but I used a 3. You see a +2, but I used a -2. Okay, there's mathematical reasons for that, but like I said, most students just go, okay, this is stupid. I'm just going to do the opposite of common sense. I see a -3, I'm going to use +3. I see a +2, I'm going to use -2. That's how most students see it, at least until they practice it a while and it gets you 100% full credit, go for it. All right, I want to erase. How are we doing? Questions? Anybody? Okay, then a new problem for you to do. So let's start over here. Suppose you have x plus 4 quantity squared plus y minus 1 quantity squared equals 3 squared. I want you to identify the center, the radius, the domain, range. I want you to sketch it. And I want you to show me the center on the sketch and news. North, east, west, south. All of that for that example. I'll pause and let you guys work. Good. So again, the HK, we take the opposite of common sense. You see a +4, we use a -4. For the Y, for the K value, we see a -1, but we use a +1. Okay, and that will work all the time. Our radius is 3, so here we go. Okay, so my center is going to be -4, 1. Okay, and I'm going to go up and down, left and right, 3. So I'm going to go up 3, 1, 2, 3. So I'm going to be at -4, 4, because 1 plus 3 is 4. Come down 3. So I'll be at -4, -2, roughly. If I go to the right 3, I'll be at -1, 1. And if I go to the left 3, I'll be -7, 1. So my drawing will look something like that. Is that okay for my drawing? For my, these, I used to call them the 4 corners of the circle, which makes a lot more sense to me. But students didn't like it because they go, how can a circle have corners? But top, bottom, right, left. I'm going to require that you show me those 4 points on your picture along with the center. The 4 points, top, bottom, right, left, and the center. Those are all worth points on yours. Domain. Is -7, oops, comma, -1. Range, -4, +4. Remember, domain is all X's, range is all Y's. Any questions on that one? Okay. Mom, again, one of the reasons I'm making homework optional or not graded is because mom has a really funky way of having you graph. It's not difficult at all. Okay. But it's not what I want you to do. This is what's going to be on the test. Mom's graphs aren't all that difficult. I'll show you how if you ask me tomorrow, I'll help you, whatever. But this is how I'm going to test you. This is how you're going to be graded on exam number 4. And actually, I think there's a circle on the final exam too. All right, I need to erase this, move on to a new topic, and then we'll take a break in a couple seconds. Are we okay? All right. Again, this is still all, all in section 11.1. Midpoint, distance formula, all this stuff about circles. Okay, they crammed a lot in 11.1. All right, I need to erase. No one's going to yell at me. Okay. Now, you know as well as I do that just when things begin to get nice and easy and understandable in math, we throw a curveball at you. We go, no, we can't have students understanding math. We have to find a way to screw them up. Okay, so here we go. Write in standard form x squared plus y squared minus 6x plus 8y minus 11 equals 0. Okay. Now, first question, what the heck is standard form? Standard form is this: x minus h squared plus y minus k squared equals r squared. That's what most textbooks and mom calls standard form. When I was taught this years ago, this was also known as graphing form, because it's really easy to graph that picture if your equation looks like this. If I gave you this equation and said, hey, graph it, you go, what? How in the world can I graph that? Okay, so the point of this question is to show you how to take this equation and using algebra, transform it here so we can get the center, which is HK, and the radius. So we're going to take this and transform it mathematically into this. All right, what we're going to use is something we learned in chapter 9 and then forgot. I taught something in chapter 9 called complete the square. I taught it as a technique for solving an equation. Okay, we did it 2 or 3 times and then we ignored it and it didn't show up on the test. Now you have to know how to use it. So let me walk you through it. The first thing we do is we reorganize the problem. So look what I did. Make notes of this. I got my x's with my x's and left room for a special x. That'll make sense in a moment. I got my y's with my y's and left room for a special y. Okay, again, that'll make sense in a second. And I moved the constant term, in this case, the negative 11, to the other side of the equation where it became positive 11. So that's your first step. Get your x's with your x's, your y's with your y's, move all the other unknown crud to the other side. Now, we talked about the special number. The way you find that special number is you take 1/2 times -6, and you get -3, but you square it. That's how we completed the square. 1/2 of this number, square it. So the magic number here is 9. and we add 9 over to here for balance. We have to add the magic number here. You'll see why that works in a moment. We have to add the magic number here. We have to add it over here to keep my equation balanced. So we do what's called, this is called completing the square on the x's. Now we move over here, we complete the square on the y's. We go half times 8, which is 4, and then we square it. So we have a 16 there, and we add a 16 there. It's always half times the single variable, the y. We call it the b number, but whatever. All right, now, the cool thing is, with this red 9 here, your x's will factor into x minus 3 quantity squared. Guaranteed. If you took the time to write that there, half times -6 is -3, and you squared it, added 9 to both sides, this will factor into x minus 3. Guaranteed every single time. Plus, okay, this will factor into y, that's a positive 4 squared every single time. So there's a reason I'm showing my steps here, not only so you guys can follow my work, but also I use that 4 twice. I square the 4 to get a 16, but I also use the 4 when I move it into factored form. That's a helpful reminder. Over here, what's this add up to? 36. 11 plus 9 plus 16, 36. All right, so this becomes x minus 3 squared plus y plus 4 squared equals 6 squared. Okay, my center is, okay, think the opposite. It's 3 comma -4. My radius is 6. Now, in a minute, you're going to do this on your own. You're also going to do this on exam number 4. Questions? Okay, the technique of getting this magic red 9 for the x's or the blue 16 for the y's, the technique is called completing the square on the x's, completing the square on the y's. All right. Let's you guys try this one. X squared plus y squared minus 12x plus 11 equals 0. Go ahead, put it into standard form and identify the center and the radius. So if we start, get the x's with the x's, get the y's with the, there are no y's, and move the 11 to the other side. Okay. So you're probably not like what I'm going to do to you, but oh well. Take half times -12 is -6, but we square it and get 36. But we add 36 to this side. Okay. Erase that. Excuse me. Now, y is already a perfect square. I'm going to jump to the answer right away and let you guys think about it. This becomes x minus 6 quantity squared plus y minus 0 quantity squared equals 25. There was already, y was already in a quantity squared. Because there was no other 3y or 8y or 2y, junk to mess it up, y was already a perfect square. Okay, so you didn't need to do anything to it. Now, what does it mean when you say y squared? It means y minus 0. So for this, our center is 6, 0. Again, remember, take the opposite of common sense. Okay, and our radius is 5, because 25 is actually 5 to the second power. So the little trick here was, what do I do with the y? When there's not extra y's, that's actually to your advantage. Less work you have to do. More thinking, but less work. All right, let's pause this. Let's take about a 5-minute break. Okay, we're going to skip chapter 11.2 tonight. There's too much in it. I'm going to spend most of tomorrow night talking about 11.2. There's a ton of stuff in 11.2. Okay, so do try to be here. Tonight, we're going to cover chapter also 11.3 and maybe some more. We'll see how we do. But it's called ellipse. An ellipse. Okay, an ellipse is a squished circle. If you take a circle and squish it by pushing it inward, like that, it kind of oozes up. What happens is when we have an ellipse, we still have a center, which is still going to be called our HK value. But something happened when we squished it in, and it doesn't matter which way you squish it. This diameter, if you will, is the longer one. It becomes the major, it's called the major axis, AXIS. Now, it doesn't matter if we squish it the other way. If we squished it long and skinny like this, then the long one is called the major axis. Okay, so it doesn't matter. Whatever's longer, you call it the major axis. And the littler one, the shorter one, is called the minor axis. So we have the major and minor. And again, major and minor change depending upon which way you squish it. But something unique happens with an ellipse. When you take a circle and you squish it, the center also splits apart. And it creates something called focal points or foci. Okay, I'll write that on the board. Okay, so the center splits, goes, and we get something on the major axis called a focal point or a foci. And there's be another one down here. It's a focal point or it's called a foci or foci. I haven't ever heard a clear answer. It's Latin something, I don't know. I don't know if it's a foci or a foci. I don't know if it's a soft C or hard C. But the good news for you is it doesn't matter. We are not going to study focal points this semester. Yes, you will come back and revisit ellipses in a future math class. And yes, the focal points will be really important. In fact, they're critically important to how to draw them, the math involved. Okay, but we're going to kind of bypass it this semester. Okay, but we have focal points and they're always on the major axis. So when you squish your circle and it kind of pops up or pops out or wherever like that, the focal points will always be on the major axis wherever you push it. Okay, so that's just a general idea of an ellipse versus a circle. Here's the formula for an ellipse that you need to know. Okay, I'm going to erase this one picture here of an ellipse. Okay, here's your formula. X minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Now, it's similar to a circle, but it's very different from a circle. Okay, your center is still that h comma k, and you still do the opposite of common sense with that pluses and minuses. But whereas a circle had one radius from the center out, it always went the same distance out to the edge of the circle. An ellipse has a multitude, of radiuses. Okay. At this point, this is the radius. But wait a minute, if you just move out a little bit, that's the radius, and they're different. And that's the radius, and they're different. And that's a different radius. So because an ellipse is out of round, it has an infinite number of radiuses, okay? And they become hard to describe. This formula takes advantage of what I call news, north, east, southwest, okay? And A becomes what's called the X radius, where B becomes the Y radius. Okay, so let me show you. We may run out of room here. Suppose we had x minus 1 squared over 3 squared plus y plus 2 squared over 5 squared equals 1. And I just made this problem up. We'll see how it goes. Okay. So right away, my center is the HKXY, but again, we use that opposite trick. I see a minus 1, I use a plus 1. I see a plus 2, I use a minus 2. And that opposite trick works only for the thingies in parentheses. Okay. My X radius is 3. Some students like to write plus or minus 3. That's up to you. My Y radius is 5. Whatever's under the X is called the X radius. Whatever's under the Y is called the Y radius. Okay, so now we graph this. We're going to go to 1, -2. We're there. Now here comes the thinking part. Okay. The X radius is 3. X runs sideways. So we're going to go 3 this way and 3 this way. 3 and only 3. So if we go 1 + 3, we're going to be out here at 4, -2. And if we say 1 take away 3, we're going to be out here at -2, -2. So I used the 3 to change my X direction. What's that, east and west in terms of news? Now, I'm going to use the 5 to measure the Y direction. So I'm going to go up 5. Okay. 1, 2, 3, 4, 5. This will be 1, -2 + 5 is 3. Okay, and I'm going to come down 5. This will be 1, -2 take away 5 is -7. So if I connect the dots, okay, this graph should look something like that. Okay. It should be taller than it is wide because my Y radius is taller than my X radius. It should be. My drawing, it's hard to tell. That's why I want you to label the center and north, east, south, west. So even if your drawing looks really spazzo, okay, I can tell by your ordered pairs that you know what you're doing. Okay, so I'm going to ask you always, just like a circle, to label the center and label north, east, south, west. Where's what? Okay, so label center. Come on, dummy. And news. Okay. For this problem, the domain, I won't always ask for domain, but you'll never know when I'm going to ask for it. On almost every picture, I might ask domain. So the domain here is all possible X's. They go from -2 to 4. My range is all Y's. They go from -7 to 3. And I'm done. And that is a question on exam 4. I will give you an ellipse and ask you to graph it and maybe give me the domain and range. I will always ask you to show me the center and then the north, south, west, east. Okay, questions? You sure? Again, mom is kind of funky. It's not hard, but her way of asking you to do the homework and what I want you to show me on a test or a quiz are different, really different. I want this. I will give you this equation here, this one, and I expect to see this graph. Okay, center, left, right, up, down. All right, so let's have you guys do one all on your own. Okay, I'll erase this. So I want you to sketch the graph of x plus 3 quantity squared over 10 squared plus y minus 1 quantity squared over 1 squared equals 1. So graph that, find the center, the radius, graph the sucker, label news, and also give me a domain and range. So sketch the graph. I got -3, 1. There's my center. My x radius is 10. So from the center, I'm going to go over 10 units. Guessing that's about 10 units. I'm just, if that's 3, then there's 3, 6, 9, and one more makes 10. I'm just faking it, guessing. But my numbers aren't guessing. -3 plus 10 is 7, 1. And if that's 10, and that's 10, and this will be -13, 1. Because I went 10 to the right, 10 to the left, because my x radius measures right and left. Okay. My y radius is 1. So I'm going to come up 1 or down 1. So this will be -3, 0. This will be -3, 2. And then my ellipse. By the way, guys, these are rounded. These don't come to points. They actually are rounded a little bit at each one of those are called vertices. Okay. So this is obviously a really stretched out sideways ellipse. Okay. I realize my pen is writing kind of fat. So if you can't read my writing, ask me. My domain is from -13 up to 7. My range is from 0 up to 2. And that's everything I ask you to do. How are we doing? Okay. I want to move into the last topic, still in chapter 11.3. It's the last topic of it. It's a little bit awkward. So I need to erase the board. Any questions on graphing and ellipse? Center is HK. You still have to use that opposite trick. Okay, opposite of common sense. We got an X radius, a Y radius. Okay, and we have a sketch with the domain and range. Nobody wants to yell at me. Okay. Then we're going to do that complete the square trick again. Remember how we took a circle and it was in some weird form and we put it in what was called standard form. So we could find the center and the radius, okay? Well, we're going to do the same thing for an ellipse, but it's significantly harder. So I do need you to kind of pay attention, okay? And I need to make sure my equations work. I hope they do. All right. So let's take 2x squared plus 9y squared minus 8x plus 18y minus 1 equals 0. Okay. Now, a couple things. If you think about a circle here, this is kind of off the deep end. It has meaning and it's important, but well, I don't know. Okay, think about a circle. It was something like x squared plus y squared minus 8x plus 2y equals, or minus 5 equals 0. One of the ways I know that this is an ellipse and this is a circle, because on a circle, the this was x squared, sorry. The coefficients of the x and y squareds were 1. They were the same. Okay. On an ellipse, they're different. So when the coefficients are different, but it's still, they still kind of look the same, almost look the same. Coefficients are different. It's an ellipse. Coefficients are the same, usually 1. It's a circle. That's how I know. Now, that's going to be a little bit important later on, but not too important. All right, so here we go. This is an ellipse. So we're going to do the same thing we did before. We're going to get our x's with our x's. We're going to get our y's with our y's. And we're going to move the 1 out of the way. Move it to the other side so it becomes a +1. Add 1 to both sides. Now, here's something I did not tell you when we talked about completing the square back in chapter 9 and a few minutes ago. You can't do it if the coefficient is bigger than 1. If the coefficient of the x squared isn't 1, you're screwed. So you're sitting there going, that means I can't do this problem, Foster. No, in math, there's always a way. What we do is we factor out the 2. So this becomes x squared minus 4x plus blank. And we factor out the 9. Y squared plus 2y plus blank equals 1. You can't do completing the square unless the coefficient of the squared term is a 1. Somehow get that in your notes. You can't do complete the square unless the coefficient of the squared term was a 1. But in the original problem, it wasn't a 1. So we had to figure out how to cheat it. And we did it by factoring as much as we needed to. In this case, a 9 out of the y's. or a 2 out of the x's. So now the coefficient is a 1. Okay, but watch. Now we go through the process. Red pen. Okay, do the same thing. We go half times -4, which is -2. We square it, we get 4. But I add 8 over here. Please, again, if you're asleep or you're watching TV, the only TV that you should be watching is either Duke or San Diego State playing Long Beach State. Okay. Really important question. I completed the square. I did exactly what I did before. Half times -4 was -2. Square it, I get 4. Put 4 here, but I put 8 over here. Why? Really important question. Why? Why? Go ahead.
They got a 2 in front of the parenthesis.
You're perfect. That's exactly right. Because I completed the square inside the parenthesis, okay, and needed a 4. But this 2, the black 2 here is still multiplying it. So to my eyes, it looks like I put a 4 here. But to the problem, I put a 2 times 4 here. So on the left side of this problem, I put 8. So on the right side, to keep it balanced, I have to put 8. Again, you put a 4 inside the parentheses, but it's being multiplied by this 2. So you actually added an 8 to the problem. That's why the 8 is over here. Okay, good answer. Thank you. Now we do the same junk in here. We go half times 2 is 1. We square it. We get a 1. Okay, that's what I put there. But I add a 9 here. Again, for the same reason. My eyes tell me I added 1. But the math told me I added 9 times 1. So I've added 9 to this problem here. So I have to add 9 over here to keep my problem balanced. Okay. So if I factor this, like I said before, this is 2 times. This is going to be x minus 2 squared plus 9 times. This is going to be y plus 1 quantity squared equals 18. Okay, we're not done. We're not done. Any questions so far? We're not done, not by a long shot. But any questions about any of my work? Why did I factor off the 2? Why did I factor out the 9? How come I added different numbers over here than I apparently added on the left side of the problem? Those are all questions you have to be able to answer. Ask while you're doing this problem. Now, keep in mind, our formula was x minus h squared over a squared plus y minus k quantity squared over b squared equals 1. That's what I said is the formula for an ellipse. There's an ellipse. Well, my problem doesn't even look anything like that. Okay. It certainly doesn't equal 1. And this problem here, there's no coefficient. This has a 2 here in front. This doesn't. And neither does the y. So I have to make my problem look like that. And the way I'm going to do it is I'm going to divide everybody by 18. That's going to make this into a 1. So that's going to give me, this cancels out, x minus 2 squared over 9 2 and 18 cancel the 9, plus y minus 1 squared over 2 equals 1. Okay. There's one more topic I want to talk about on this problem before I give you another one to do. Do you guys understand why I divided everybody by 18 and how I did that and got this answer here? Okay. So what's my center on this ellipse? Okay, the center of this one is 2, 1. Take the opposite of what common sense says. 2, 1. My x radius, be careful, is 3. Huh? Think about that. I actually have to write it as quantity squared. So instead of writing 9, I should have written this as 3 squared. That makes my x radius 3. What about my y radius? What is it?
Square root 2.
Bingo, perfect. The y radius is the square root of 2. How come? Because 2 is the square root of 2 squared. And remember, we're comparing our problem against the formula. I need to have quantity squared, a squared, b squared. Now, I would not, at this level, of course, ask you to graph where the y radius is the square root of 2. I wouldn't do that to you. Okay, that's a future course, maybe. Okay, but you do see it. I could ask you that question. I could say, here's a problem. Tell me what the center and the x and the y radius are. Okay, and you would go through all this work and pull out this information, but you didn't have to graph it. Okay, I want to erase this and have you guys do a problem on your own. How are we doing? Any questions? Anything needs clarification? All right, then on your own. Okay. Again, write this in standard form, telling me the center, the x radius, and the y radius. 25x squared plus 4y squared plus 50x plus 48y plus 69 equals 0. I'll give you a minute or two. Okay, so here we go. 25x squared plus 50x plus a blank plus a 4y squared plus 48y plus a blank equals negative 69. Okay, cannot complete the square unless the coefficient is a 1. So we trick the problem by factoring out of 25, giving me a 1x squared plus 2x plus blank. Factor out of 4, trick the problem, give me a 1y squared plus 12. Yeah, 12y plus blank equals negative 69. Okay. Take half times 2 equals 1. Squared is 1. But I add 2 times that, 25 times that, so I add 25. I needed a 1 inside the parentheses, but it's 25 times 1, so I add that to the other side. Over here, I do half times 12 is 6, squared is 36. Okay, but what do I add to the other side? I believe I need to double check that, but I think that's 144. 4 times 36, that's what I've added to this, so I have to add the same amount over here, 4 times 36. So let's see, what do I have? This is 25 times x plus 1, quantity squared, plus 4 times y plus 6, quantity squared, equals, I don't know, calculator. Is that 100? Yeah, it's 100, isn't it? I don't hear anybody yelling, so I'll double check it. Yeah, it's 100. I'll be damned. Okay. Now I need to make it equal 1 because it's an ellipse. Remember, how do I know it's an ellipse? Because your x squared coefficient and your y squared coefficient are different. When they're different, it's going to be an ellipse. If they were the same, it would be a circle. And usually they're 1 if it's a circle. Okay. So I got to divide everybody by 100. Simplify. X plus 1 squared over 4. 25, 100 cross cancel. Y plus 6 quantity squared over 25 equals 1. My center is -1, -6. Remember, we take the opposite of those. My x radius is 2, square root of 4. It's 2. My y radius is 5. Square root of 25 is 5. Okay, I want to show you one thing, and then we're done for the night. Question anything before I erase the board and show you one thing? You're sure? Okay. While I'm erasing the board, tomorrow night we will do section 11.2. And like I warned you, it's got a ton of stuff in it. We're going to spend 99% of tomorrow night on section 11.2. It's got so much stuff. It's all about parabolas. A parabola is a U-shaped curve. Up parabola, down parabola, but parabolas can also go sideways, left, sideways, right, all kinds of things. We're gonna cover parabolas like you've never seen, and we're gonna do word problems with parabolas. Remember those rocket problems where you shoot rockets in the air? We're going to come back and use those again. So tomorrow night's going to be a big time night. Try to be here if you can. Okay. In Math 104, which is trigonometry, which nobody could spell, so we just abbreviate it TRIG, trigonometry. Okay. They start almost at the beginning of the course with something called the unit circle. Okay. What the unit circle is a circle whose center is 0, 0, and whose radius is 1. Now, you also will hear the word origin. Origin and 0, 0 are synonymous. They'll talk about a circle whose center is at the origin. Well, the origin is still 0, 0. They're the same words or the same vocabulary. Radius is 1. Almost from the very beginning, okay, in Math 104, they will talk about this unit circle. This is the circle x squared plus y squared equals 1 squared. But they will also confuse you because they'll say, but wait, 1 squared is its only is itself. So they may leave off that little 2 out there. Okay, it's supposed to be there, but they don't bother with it. Okay, and everything they do is then around this problem. This is the ordered pair 1, 0. Remember we did news, northeast, southwest. This is the ordered pair 0, 1. This out here is the ordered pair, whoops, -1, 0, and this is 0, -1. So this is what's called the unit circle. And again, in Math 104 and again in Math 141, they pick it up again. Those of you who are STEM students and need to take those courses, okay? They, after some weird stuff, the first week, they do weird junk. And then almost immediately they jump into this thing called the unit circle. Unit is just a fancy way of saying, hey, dummy, its radius is 1. Why don't they call it a radius 1 circle? I don't know, because unit sounds fancier, but they have the unit circle. That's its equation. It's centered at the origin. Here's the center, which is 0, 0. And it has these ordered pairs at its corner. And they will do so much math with this picture. Okay, you'll go nuts. Okay, so I'm just kind of giving you a heads up. It's related to what we're studying, but our circles have different size radiuses. Okay, not just a 1. And our circles are off center. They're not centered at the origin, but they're still there. So there's a big giant tie-in between what we're doing and what you'll be doing in Math 104. All right, see you all tomorrow. Don't forget that PDF quizzy thingy if you have a smart phone and an app on it. See you guys later. Bye-bye.